Okay, welcome. I've been giving these bonus problems on these quizzes and tests that we've been having over Quadratics, and the main reason is because I want to get you guys more used to analytical reasoning. So what I'm going to do with these videos is show you how to work out these problems, and also kind of show you that it's not quite a big deal on some of these problems. They look more complicated than they are. Alright, so let's start with this problem here. If n is greater than 0, and 9x squared plus kx plus 36 equals 3x plus n squared for all values of x, then what is the value of k minus n? A lot of students just freak out just because of the sheer number of letters in this problem instead of numbers. But let's remember this identity, meaning two things that are equal. So 9x squared plus ks plus 36 is the same value as 3x plus n squared. Well, let's expand the right-hand side here to get a better idea of what that looks like. So 3x plus n squared. So if we multiply 3x plus n by itself, or square it in other words, I usually have students think about this as just the FOIL method. You do have to multiply two separate binomials. And if we use FOIL here, you find out the first term, or the quadratic term is first times first, which is 3 times 3 is 9, and this is x times x is x squared. So the thing is 9x squared. Your middle term is going to be 3nx plus 3nx. So that's going to give you 6n as your coefficient for your middle term. And then the last term is just n times n, which is n squared. So that whole thing is the same thing as this 9x squared plus ks plus 36. So let's set those equal. Let's see, 9x squared plus some value kx plus 36. So what this tells me is because those two are equal, that their coefficients all have to correspond. They all have to be equal. In other words, let me color code this for a sec. 6n, that value, is the same as k, since they're in the same positions. N squared has the same value as 36, since they're in the same positions. Let's take that, because that gives us an actual value for n. If n squared is 36, take the square root of both sides, so n must be equal to positive 6. And it's only positive 6 because of this. N is greater than 0. N can't be a negative number. So n has to be positive 6. So let's take a look back at this yellow identity that I've highlighted. And I don't like to write in yellow, so let me write this in red. The value 6n is equal to k. And guess what? I know the value of n, so I can just plug that in. So 6 times 6 is k. K is 36. What's it asking for? The value of k minus n. So 36 minus 6. The answer is then 30. D. Okay, bonus 2 says, for some constant r, the graph of the quadratic function f of x equals negative x squared plus 2rx is a parabola with x-intercepts at P and Q and vertex V. What's the area of a triangle PQV in terms of r? So I'm going to start off by sketching this. And let's get a good sketch of this function. Now, without even, there's no number here for r. It just says for some constant r, and everything's in terms of r. So I can't get an exact sketch, but I do know a few things. The a value is negative 1. The value in front of x squared is negative 1. So my parabola is going to open down. It's going to be concave down, meaning my vertex is going to be a maximum value. If you notice, there's no constant term on this, so that means I must have an x-intercept of 0. To clarify that a bit, let's look at this. Negative x squared plus 2rx. From that, you can actually factor out an x. And you're left with negative x plus 2r. because I can factor that x out like that, I know that if I was going to set this equal to 0 to find my roots, x equals 0 is one root. So I do have a root at the origin. I also have a root somewhere over here. And they're actually giving us the names of these roots, are the x-intercepts, p and q. It opens downward because of the negative x squared. So this is your parabola. It's poorly drawn, but you'll have to excuse my drawing. The vertex occurs at the value, well, they're calling it V. And what we're looking for is the area of this triangle that I'm going to draw here in, what do you call it, in dashed lines. We're looking for the area of that triangle. So for the area of a triangle, we need to know the height. So I need to know this value. Let me make that red. I need to know that length. That's going to be my height. And it's perpendicular. I also need to know from here to here, that's my base. And then I can find the area of that triangle. Area of a triangle is given by 1/2 base times height. So let me see what I know. Is there a way to find the vertex, to easily find what the value of the vertex is of this parabola? Turns out there is. There's a formula to always get the x value of the vertex, and it's negative b over 2a. So what's my a? My a is negative 1. My b is 2r. So if I did negative b, which is negative 2r, over 2 times a, which is negative 1, just substitute that stuff in. Let's see what we can cancel out. Let's see if we can simplify it. That's negative 2r over negative 2. So these two cancel, and I'm left with just r. So what I'm saying is, the x value of my vertex has to be r. In other words, the distance from here right to the middle is the value r. It's halfway, it's half of b. It's halfway between. And now let's find the y-coordinate. Well, to find the y-coordinate, just plug r into the original function. So f of x equals negative r instead of x squared plus 2r times r. Simplify. This is a negative r squared, and this is a plus 2r squared. Combine like terms, 2 minus 1 is just regular old r squared. The vertex then is r squared, that's x and y. So my height, my y-coordinate is r squared, if you're looking at the triangle. Therefore, the area of that triangle is given by 1/2 the base, and the base is not r, it's actually 2r, since r was just half, times the height, which was r squared. When you simplify, 1/2 times 2 cancels, those cancel, so we're left with r times r squared, which gives me r to the 3rd power. The answer is B.